Hey everybody, looks like we are getting into probability number 2, so probability worksheet number 2. Let's go through this and let's see how it varies from probability 1. It's not a big difference, just a little difference, but you need to pay close attention to it or else you won't figure out what's going on. So let's see what's going on here. Alright, looks like we're ready to go. So our first example from, this is something we could have done in probability 1. Let's say you have a row of 5 students, and let's say you want to choose 2 students from that row to shake hands. How many different groups of 2 can we make? How many handshakes could you make? Well, according to the last lesson, you would have gone with the number 20 as your answer. You would have said there are 20 different ways that these students can shake hands, because you would have said, well, I've got 5 students to choose from, and as soon as I've chosen one of them, that leaves me with 4 students left, so you would have said 20. Yeah, there's a problem. That's wrong. The last lesson was good, but it doesn't always work. Here, let me prove it to you. Let's say there are 5 people in a row, and we're deciding who's going to shake hands. So let's say the first person and the second person shake hands. First and the third, first and the fourth, first and the fifth. Okay, then let's say the second person shakes hands with the first, second with the third, second with the fourth, second with the fifth. And let's keep going. Third with the first, third with the second, third with the fourth, third with the fifth. You get the idea. Some of you are probably already looking at this and you're saying, wait a second, there's something wrong here. Now I see why this doesn't work. Maybe you do, maybe you don't. Let's find out. Almost done. So those would be the 20 combinations based on what we learned in the last lesson. Those are the 20 different ways that people could shake hands. Here's the problem. The first person shaking hands with the second, isn't that the same as the second person shaking hands with the first? Isn't that a repeat? When you shake hands, is there really a first person and a second person? No, you're shaking hands. It's not like, the first person is in control of the handshake and the second person is just standing by. It's not like that. When you make handshakes, there is no order to it. The first person shaking the hands with the second person, that's the same as the second person shaking hands with the first. This is a repeat. That doesn't count. In fact, if you look really closely at this list, you find out there are a whole lot of repeats. So it turns out the answer to the question isn't 20, because by the time you divide out all the repeats, you find out that really it's not 20. Really it's 2, 3, 4, 5, 6, 7, 8, 9, 10. The answer is not 20. The answer is actually 10. And that's what confuses a lot of people, which is why we have to learn something new. So why did yesterday's lesson not work? Well, when we find real-life situations where order doesn't matter, you have to use a different method. You have to use combinations instead of permutations. There you go. So, when do we use each one? When do we use the lesson that we learned first in probability 1? Well, if it says orders or lineups or arrangements, order matters. If I'm making a starting lineup for a baseball team, I don't want my best hitter hitting last. That would be stupid. So when you're making a lineup, order matters. You want your good hitters batting second, third, fourth, fifth, maybe even lead off, something like that. If you're arranging a picture, order matters. So all of those would be examples of situations that use permutations. Passwords. Does your order matter when you're choosing the letters for a password? Absolutely, so it's important. If you're in a contest, if I'm running a race. Is there a difference between first and second? Of course there is. So those are situations where you would use the old method. Today's method that we're going to learn is when you're making groups. Order doesn't matter, you just want a group of 3. Or you just want a group of 4. Or let's say committees. Same thing. There was no leader to the committee, it's just a committee. Or this sounds really silly, but toppings on a sundae or on a pizza. Do I care if the person making my pizza put the green pepper on before the mushroom? I don't know what they did. Order doesn't matter when you're talking about toppings. Okay? So if you get a problem that involves that word, you need to use a combination. So mathematically speaking, the difference is in the formula, instead of having a big P in the middle, you put a big C in the middle. And then there's an extra little division step right there. So the formula is the same as the other formula, just with an extra little division step. All right, so we're going to try this problem, and we're going to try it out using 2 different methods. Okay? So first, we're going to try it using blanks, which is what we actually did with permutations, but we're going to mix it up just a little bit. And then we will try this once using the formula. So here's the problem. A group of 3 is being formed from 6 candidates. How many ways can this occur? Now it's just a group. Let's say it's a school board election and you're running for 3 spots. There's not one spot ahead of the other, you're just running for 3 spots. How many ways can this occur? Well, in the last chapter, or in the last section I should say, we made 3 blanks. There were 6 choices for the first spot. As soon as that spot is chosen, that person is now out of the running, so now there are only 5 people left. And then after that, there are only 4 people left. That was the old way using permutations. We're still going to use that way. There's just an extra division step. And I call it the combination count up. It's cheesy, but it works. Just work with me here. Start with the number 1. I want you to write 1 down below here. Then count up. I want you to write 2 down below here, 3 down below here, and then you're done. So if it's a combination, I want you to use what's called the combination count up. Okay? So it's the same formula as for a permutation, but if order doesn't matter, you have to do a division step at the end. I call it the combination count up. Anyway, with a calculator, you could just do 6 times 5 is 30, times 4 is 120. If you look at the bottom, 1 times 2 times 3 is 6, and 120 divided by 6 is 20 ways. Would the formula give you the same answer? Yes, it would. Because if you use the formula, this would be a 6C3. There are 6 people, and you are choosing 3 of those people. So you would put 6 factorial on top, and then you would do 6 minus 3 in parentheses, another factorial, and then you put another 3 factorial right there. Now, 6 factorial is 720. 6 minus 3 is 3. And 3 factorial, 3 times 2 times 1 is 6. So I'm going to put a 6 down here. And then I have another 3 factorial, so I'm going to put another 6 down here. So what you would end up getting is 720. That was the worst 0 ever. Okay, 720 divided by 36. And guess what 720 divided by 36 is? This is a total shocker. 20 ways. Same answer. Now, I personally don't like the formula. I think the formula is obnoxious. But I have seen it tested where instead of asking you how many ways is this going to happen, the test just says, hey, set up the formula. So you need to know the formula because sometimes you're going to take a test where they're going to ask you, hey, can you set up the formula for me? Okay. Let's go to number 3. You have 8 friends, but only 4 of them can go to the concert with you. You will be sitting on the lawn, so order doesn't matter. How many ways can you choose who can go? So you have 8 friends that want to go to the concert, but you only have 4 seats. So this is an 8C4. Order doesn't matter because you're just sitting on the lawn anyway. So you don't even have seats. So you can't just say, oh, well, it's important I sit in this spot. No, shut up. You don't know what you're talking about. If you've ever been on the lawn for a concert, you're walking around. You're usually not even sitting down. So start the way we would have done. 8 friends to choose from. As soon as you've chosen 1 friend, now you only have 7 left. Then you have 6 friends. Then you have 5 friends. Now, because order doesn't matter, because it is a C instead of a P, you have to do the combination count up. That means you just start at 1, and then you just keep writing. You keep counting up until you run out of spaces. 1, 2, 3, 4. There you go. All right, so in this case, 8 times 7, 56. 56 times 6 is 336. The top number will be 1680. Sorry, I'm just sort of doing this in my head, so just work with me for a second. 1 times 2 is 2, times 3 is 6, times 4 is 24. 1,680 divided by 24, so then you divide those out, and you find out there are 70 different ways that you can take your friends to the concert. Not that you're actually going to sit there and count the ways, but that's just the way the math works. All right, let's move on to number 4. If I'm going too fast, it's a video, so just pause the darn thing. It's okay. A pizza place has 11 toppings to choose from, and you are going to order a 2-topping pizza. How many pizzas could you choose from? Well, same setup as before. There are 2 blanks because you're going to choose 2 toppings. So this is an 11C2. Order doesn't matter. Remember, it's like I said, I don't care if they put the mushroom on before the green pepper or the mushroom on after the green pepper. It makes no difference to me. Order does not matter. So we're going to do the same thing we did in the last section. 11 choices for the first topping. As soon as you've chosen that first topping, you have 10 choices for the second topping, but we're going to do the count up. So 11 times 10 is 110, but 1 times 2 is 2. We're going to divide it by 2. So 110 divided by 2, you find out there are 55 ways to make the pizza. All right, number 5 has 3 stars by it because it is extra tricky. So what I'm going to do, I'm not going to say a word about it. If you decide you think you have an answer, email me. I'll tell you if you're right or not. Give me a good explanation as to why you think the answer is what it is. Maybe let's do like first 2 people from every class get 5 free quiz points on your probability quiz. Let's have some fun with it. So first 2 correct emails from each class. Let's just go with it. Sounds good. So 6 through 15, maybe we'll do 1 more of these just for good practice. And then I'll have you do the rest on your own. So let's say 7C3. So there are going to be 3 blanks because you have 7 items. You're going to choose 3. So you have 7 choices, then 6, then 5. But because it is a combination, we're going to do the combination count up. Start at 1, count up until you run out of spaces. Oh, that looks to me like you're going to get 210 on top. 7 times 6 is 42, times 5 is 210 divided by 6. So it turns out 7, choose 3 is 210 divided by 6, which I'm pretty darn sure that's 35. All right, so before I leave you alone, there are some technicalities I want to talk about here. What is 10C1? How many ways can I choose 1 item out of 10? Well, how about 10? You've got 10 choices, right? So you're going to make 1 blank. Remember, the number on the right is how many blanks you're going to draw. And you're going to divide by 1. So 10C1 is 10. Now, 10C10, this is going to be kind of funny because it gives you the same answer. It's just kind of scary as you do it. So you have to make 10 blanks, and then you have to go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. But remember, it is a combination count up. So you end up getting on the bottom, so I was saying about it being the same. It's the same number on top as it is on bottom, because if you're going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It turns out, if you were to go through this really carefully, you'd find out that the 10s cancel, the 9s cancel, and so on and so on. It turns out everything cancels. So when all is said and done, you just get 1. It's the same answer on top as it is on bottom, the same number on top as it is on bottom, so you get a final answer of 1. I think that's pretty funny. So basically, if the number on the left and the number on the right are the same, and it's a combination, your answer is actually just 1. Last question. It's a trick question, but I've seen it, so it's a good conversation. What is 10C0? So you have 10 items. I have 10 students, and I don't want to choose any of them. Am I allowed to do that? Well, yeah, I'm allowed to do that. I'm just not going to choose any of you. So there is one way to do it. I could do it by choosing nobody. Let's say there's a scholarship opportunity, but I have 10 kids and none of them really fit the criteria for the scholarship. I could just go back to that scholarship corporation and say, I nominate no one. Now, would I want to do that? Of course not, but it's just the example I'm using here. So the answer to that would be 1, because there is one way that I could do that. It would be by choosing no one. So anyway, fill in 6 through 15, the rest of it on your own. Try number 5 for extra credit. I hope you guys have a great rest of the day, and I'll hear from you soon. Thanks a lot.